So if the volume's not 0, it's big enough within range, then it'll actually play it. Otherwise, it won't play it. Okay, I went ahead and I tightened the collision detection a little bit. The moving up part is pretty much exactly the same. It's just setting it to the previous positions and setting the velocity y to 0 if it hits something vertically, like above it. For moving to the right, I now have it test right with +2, +1, and +1 with y minus 1. And the reason why I do a +2 now is because one of the monsters is really wide, so we almost have to do a sweeping test. We start at the furthest position and work our way back. So if he is greater than +2, it'll pull him back to the +1, and then if he's there, it'll pull him back a little further. We do the y minus 1 last because we want to work with his feet first. And then for moving left, we do the same, except we call it testing left, or test left, because it's slightly different. And I'll show you these two methods in a second here. I've practically just taken the code that used to be in here for one of these and put it in there. So this will check 2 to the left, 1 to the left, 1 to the left, and 1 left and up, I should say. And we want to do it in that order because that'll give us the best collision detection results. And the half width variable I took out of here and I put it in these each. So I'll show you those methods. Test left. Because we do the -2, there's a chance that we're going to be looking at a tile that's out of bounds. So I just do this precautionary check. If it is out of bounds, then it'll just set the position to the old position and the old location and then return. Otherwise, we can do a more precise collision response. I'm taking half the character's width and subtracting 10 to give him a little extra freedom to move into the tile by about 10 pixels. Well, the bounding box is not all that tight against the character, so you might even want to increase this a bit to say like 15. So that kind of shrinks the bounding box a little bit. So first we check if it's solid. If it is, like this would be x minus 2 or x minus 1, we're checking to see if it's solid, and the same with this. You just got to keep that in mind. Then we check to see if it passes through the left side of it. So pose x minus half width. That's the center of the character, minus half the width is less than, if this is x minus 2, then it would be x minus 2 times 64. And then before we had if on spikes and if tile spikes, then we had the little brackets, and then we had else. We weren't actually going to do anything with that, I realized, so I just changed it to this, which is the equivalent logic. If not this or not this, then we can do this. So what I'm doing here is I'm setting the position, which is the center of the character, to be 64 pixels to the right of the left side of the tile in question, so the right side of that tile, plus half the width because the center is half the width to the right of the left side of the character. You can kind of do the algebra too, like we want position x to be equal to minus half width to be equal to x times 64. So then you solve for position x and you say plus half width on this side, and then you'll get x times 64 plus half width, and that's what this is doing. And then we have to get the location on the map, so every 64 pixels is one tile location, so we just divide the position by 64. You'll notice that we're saying minus half width less than x times 64, and test right's different. This part's the same. We make sure it's within bounds. Same with the half width thing, it's the same. And if it's solid, then we can check if the position plus half the width, which is the right side of the character, is greater than the left side of the tile in question. And if it's not spikes, then we'll set the position to be the left side of the tile minus half the width, because the position has to be the center of the character. And then again, we just divide by 64 to get the map location. And I already went over test down. I don't know if I explained it very well, but hopefully you get it. And testing it out, you can see the collision detection and response is a little tighter than it was before, meaning it's more accurate. For the half widths, I changed the tolerance to -10 instead of -15 because it seemed to be a bit too much. And in test down, added this test left where it says h offset is 0. So now if h offset's greater than 0, it'll do this check. And what this helps to do is it helps to prevent the characters from, I guess the best way to explain this is sometimes when it's checking a tile down and to the left and it sees that there's something below him, it'll try to position him on top of that tile. However, that's not always the best response that we would like, because it might see that his feet are about to go into that tile, and the tile up above it is also solid, and the one up above that's solid. So it just keeps pushing him upward. If we do this test left test left first, it'll push him out of that tile over to the right, and we can do the same thing here too. Test right, make sure he's not too far in, and kind of push him to the left, so that way he won't slide up the blocks. And this is all stuff that you find out from testing it, and you realize what it's doing and you figure out how to fix it. After some further testing, I realized that these are not actually necessary, so we can take those out. These extra brackets here and here, though, to make the distinctions between which ones are forming the else if are necessary. Otherwise, you'll have the wrong logic here. There is a bug in this. If we go down to here for test left, I noticed that the monsters fly up through the level, and I couldn't figure out what was causing it. And I see that right here, we need the right side. So this should be +1, because we want to test it against the right side of the tile going left, and that should work. In the player class, which is where I am right now, in World Collisions, for moving right, I added a test right +2, a test right. This one might not be necessary, but it's just a precaution. He could be moving very quickly. So to replace this code, I use these, and same here, test left. And all I really did was copy the code out of the monster class and modify it so that we're using half player width, and I made that correction to the test left. So half player width in 2 places here. If it's solid, if the middle of the character minus his width, or half his width, is less than the right side of the tile, then we check this and we set his position so that it's the right side of the tile, which is x times 64 plus 64, plus half the player width, which would put his center half the player width to the right of that right side of the tile and get the correct location. And for test right, it's pretty much the same thing. Make sure it's within bounds, check if it's solid, check to see if the right side of the character goes through the left side of the tile, and in case it's not spikes, we'll set the position to be the left side of the tile minus half the player width so that the center's over to the left. We'll get rid of that -1, we don't need that. And I set the x velocity to be 0, and I did that in the monster too. Let's change it to 0 so he's not continuously trying to go through the wall. You don't have to do that because it'll stop him anyway, but it'll look like he's trying to walk into the wall constantly. He'll still try to kind of walk, but I'll slow him down quite a bit. So now when we test the collision, you can see it's a lot more accurate. You might even want to give him a little bit of room to go into the walls, a little, especially to the left. To the right it looks fine. Oh, I know why. Because right here we're on a boundary and it's stopping them based on position, last location. So we could fix that. Okay, I fixed it. Now he hits the wall and kind of stops. Looks like I gotta fix the collision detection for up above him now. So all I did to fix this was, instead of using this and using old position and old location, I just say if x is less than 0, make it 0, and if x is greater than or equal to the tiles wide -1, and we set it to that. And we got to do the same thing for the other one. And that should fix those. So all I did to fix the player jumping up, getting caught in the tiles a bit, is I added this y-2. So I just copied this to here and changed y times 64 to y-1 times 64 because we're an extra tile up. So that would be for the bottom of it because it's plus 64. That's why it's only -1 instead of -2. And this works good enough for this. I also changed the order of this too so that the moving right, moving left stuff is checked first and then the up and down stuff's checked after. So as you can see, it doesn't get caught on anything anymore. Now we're going to make it so that you can have the monsters attack the player or players. In the AI section for the monster, go to the chase region, and where we've discovered right here that the player is somewhere within range of the monster so that it can chase you, let us also check to see if it's within range that it would want to try to attack you. So we'll say the left side of the monster is the position plus bounding box X offset, which is up and to the left of the position, which is the center of the monster. Say the player left is just the player bounding box X, which is an actual normal bounding box. And float right is going to be left plus bounding box. Wait, then you can say player right is player dot bounding box Z. That's a vector for. And float top position dot Y plus B box dot Y. Should get the top of the monster. And player top, player.bbox.y. and bottom of the monster is top plus bbox.height, and player bottom goes player.bbox.w. So I'll add some padding to that rectangle that this basically forms. The extra region that would cause the monster to try to attack. So constant float x range is 100, y range is 70. So are we in range to attack? If right side of the monster is greater than the left side player left minus x range, so we want some extra range, sort of a bigger space around them, and if left is less than player right plus x range, and the bottom is greater than player top minus the y range, and the top is less than player's bottom minus y range, and let's see here, be one greater than sign, then we can begin an attempted attack. If the last motion was not an attack, then we can begin an attack. So we'll set motion is an attack, and then it'll set that animation and down below. So switch monster type, because we got a type up here. Which type of monster is it? Case monster type dot monster, and we'll say monster system monster attack 1 play based off of the calculated panning for this monster. And if it was like a monster truck or something that the engine's always running, we'd have to use a sound effect instance so we can continuously adjust panning for it, because these are one-shot sounds. So you just kind of send off the sound and let it do its thing until it's done. Monster system, monster attack, 2.play, pan.y, 0.8f, pan.x. Break. That's all the monsters we have. So if the attack is already initiated, say else if motion is indeed attack. I'm just putting this in here to be clear. If the meow player key 1 is greater than the attack key, that's the keyframe where the attack can actually hurt you, which we set up before in the properties, and player.invincible is not happening, then, and this is where we test to see if it actually hits the player. So we've got to adjust the top position first, because we don't want that extra range on there. It'll be the position of the monster plus the attack box .y. So we'll get the correct offset, top left-hand corner of the attack box. So that'll be the top of it first. The bottom would be the top plus the attack box height. And if not flipped, so under normal circumstances, we're going to say left equals position dot x plus the offset to get the attack box top left corner, left in this case, and I'll say right is the left plus the width of the attack box. Otherwise, it is flipped, so we got to say right is position.x minus attack box.x, flipping everything backwards horizontally. Left equals right minus attack box dot width, and because this is a negative, this actually becomes an addition, the position, which is the center of the character. And then to get the left side, we have to take that right side and subtract that width. Now we check for a hit. If the right is greater than, right side of the attack box is greater than the player's left side, player left, and the left is less than the player right, and the bottom is greater than the player's top, and top is less than the player's bottom. We know it's within attack range, such that the attack would actually hit the hero in this case for sure. Then we can say player hero damaged and give them 0.2f damage. We could also set it up so that it sends in a damage amount based on the monster type, so that would be set in properties ahead of time. I found an interesting bug that seemed to be throwing off some of my numbers, which is why I had to keep making adjustments. This was width, and it needs to be height, and that's adjust scale for resolution or screen resolution in the Meow Motion player. So our rescale value was wrong, which was throwing off some of our calculations, and I had to keep making adjustments, and I couldn't figure out what was going on. We'll have to go back into get monster properties again and monster and just change these values here, 12 and 11, because everything was out of whack. I noticed another bug in the player class. Before we had grounded being set out here, but we don't know that he necessarily landed on a tile yet. Grounded should actually be in here where if h offset equals 0, so all these conditions are satisfied. So if he's partly on a tile, we don't want him to be able to jump off of the edge of it if he technically wasn't partly on that tile, and this would determine that as well as this. So we have to put grounded in here. And while we're in player, go to the top of world collisions, and right after we set the screen position to be the world to screen from the world position, we'll set the bounding box for the player so we can do collision detections. Okay, it'll be a vector 4, so get the top left-hand corner, the position X, and I'm just going to hard code these, could have it calculate them, but we know the screen resolution isn't going to change, so we're not worried about it. So you'd have to alter this to match your character. This is the left offset from the center to the top left sort of bounding box region, and you can just tweak that by looking at the region where it draws it, and then that would be the top, that would be the right, and the bottom. So it's kind of like a rectangle, but we're using a vector 4 and just getting the top left and bottom right corners. So if we watch, you can see my white rectangle, which is that vector 4 I set, versus his red rectangle. You could just keep adjusting those offsets until it looks good. Okay, going into the monsters update, we'll go into where it says if invincible is less than or equal to 0, meaning that possible to attack the monster. We'll make this into an attack section for the player, so the player's fireballs. And the fireballs don't have to be visible, they can still hit the monster even if they're off screen. Say constant, integer, radius, set it to 32, so basically tile sized. Radius 2 we'll set to 64, so that's the radius times 2 diameter. And then we'll create a rectangle called bounding rec, or bound rec. New rectangle, casting to integer, the position of the monster plus the bounding box offset to get the top left corner, comma, position.y plus the bounding box.y, and just give it the bounding box width, an integer for the bounding box height. So now we have a proper bounding box for the monster. In fact, we should probably make this a member of the class and just do it once, and then it doesn't have to do it every loop. So I'll just leave it for now, it should be fine. Int I is 0, while I is less than player spells count. We're going to go through all the spells and check to see if they hit them. Okay, vector 2 screen position is going to be player.spells I.emit world position. Then we'll create a rectangle for the spell. Spell rectangle is equal to a new rectangle, cast integer, screen position .x minus the radius. The left side, right side, or I mean the top side is going to be screen position .y minus radius. Radius 2, radius 2. We could just do a distance check too. We'll do it like this. Got an equal sign that should be here. If spell rect.intersects, I just wanted to show the intersection of rectangles. Bound rectangle, then we'll say monster damaged. Player.spellpower, that'll determine how much damage it did. And that should do it for that. Attack me, will ya? Oh, looks like we needed some explosions, because that just doesn't seem right at all. I gotta fix that chainsaw sound. I like the Monster sound, but the chainsaw sound sounds strange. Alright, the next thing to take care of is creating an animation class for sprites. And we'll first start actually with making a texture map that contains all the explosion images.